Okay, now let's talk about properties of logarithms. And the properties of exponents correspond to the properties of logarithms, and that makes sense because, well, logarithms are exponents, right? So that kind of makes perfect sense. So let's look at first the exponent rules, and then we'll look at the logarithm rules. So the product rule for exponents: when you multiply the same bases with exponents, you add the exponents, right? So if you have x raised to the m times x raised to the n, you have the same bases, so you add the exponents, which is equals x raised to the m plus n. Now this property suggests the following property of logs, which is called the product rule. Okay, so the product rule for logarithms states this. These are the rules of the game. You have to let b, m, and n be positive numbers, real numbers, and b cannot be 1. When we have these stipulations met, then log base b argument is going to be m times n. Then this is going to equal log base b m plus log base b n. So we can see that our multiplication turns to addition. Okay, so the log of a product is the sum of logarithms. So multiplication goes to addition. But this goes both ways, okay? So multiplication goes to addition, but addition also goes to multiplication later on when we get to condensing. So when we take a single logarithm and turn it into 2 or more logs, this is called expanding. So that's what we're about to do. We're about to do expanding. So using the product rule, expand each logarithmic expression. So we have log base 4, 7 times 5. So what's that going to equal? It's going to be log base 4. We always start left to right, log base 4. We get to our first argument, so log base 4 of 7. Now we have a multiplication sign, so we're going to write an addition sign. Okay? And we're going to start over. Log base 4, and then we go to our second argument. Okay? When we don't have a variable in our argument, we always stop to see, is there anything that we could raise 4 to give us 7 evenly, right? Which that's no. Anything we could raise 4 to give us a 5 evenly, and that's no. So now we roll on. Okay, let's do the next one. So here we have, let's write this. It could be written, there's like a little multiplication sign right there, right? So this would be log of 10 plus log of x. Now, when it's just simply log and there's no log stated right here, what is the implied base? I really hope you said 10 because that would be correct, right? There would be a base 10. So since we have a base 10 here, we're going to ask ourselves, there's no variable in the argument, so what can we raise 10 to, what power, to give us 10? That'd be 1, right? So if you can't figure that out, we could do log base 10. No, let me write that over again, good grief. Log base 10 of 10 equals y. So we do our arrows, right? 10 to the y power equals 10. And we know that there's always this little implied 1. If we cancel, y equals 1. So we can, since 1 is the exponent, that's the answer for this one, we could say 1 plus log x. Okay? Right on. Let's look at this one. This one's a little more complicated. It was a problem I found in this book, so it's likely to have maybe some homework problems like this one, so I wanted to give it to you too. So we're going to have, there's a multiplication sign right there between the two, so we would definitely break that apart. So we would have log a of x now plus, go back over here, log a of the square root of x squared plus 1. Okay, but we know that whenever we have anything under an even root, we could rewrite it as, I'm going to do it with just a plain old x because it's shorter, but if we have the square root of x, we could always rewrite that like x to the 1/2 power, right? Because there's a little implied 2 here and a little implied 1 power here. So the 1 goes to the top, the root goes to the bottom. Okay, remember that whole thing? So now we could rewrite this like log base a of x, and then we get plus log base a of x squared plus 1 to the 1/2 power. Now, last thing that we want to do is we want to take this power, not pink, we just use pink, bring this power to the front. Okay, so this is going to be log ax plus 1/2 a x squared plus 1. Okay, that's how you would do that. If it has a power, your power always moves last, but it moves to the front of this log. Okay. So here's the quotient rule for exponents. So when we divide the same base, we subtract exponents, right? So we have the same base b, m over n, we subtract n from m. So this property suggests the following property of logs, and it's called the quotient rule. So the quotient rule for logs has the same rules, right? B, m, and n have to be positive. B cannot be 1. So when this happens, we have log base b of m divided by n, and that's when division goes to subtraction. Okay, so we have log base b of m minus log base b of n. So here, division goes to subtraction. Remember, this goes both ways as well. Okay? So, the log of a quotient is the difference of logarithms. So, the way I remembered this, I know you're all thinking, oh no, here she goes. But the way I remember this in college algebra is a long division bar turned into a short subtraction bar. Okay? So for this one, we're going to have log base 7. Always the one on top goes first, minus log base 7 of x. Okay? Again, ln e of 3 minus ln of 7. Okay, when it's an ln, what is my implied base? It's e, right? So we have to stop and ask ourselves, what power would we raise e to get e to the third? Well, that would be 3. So this is going to be 3 minus ln 7. Please don't try to add these. This is a whole number, and this is an ln. Apples, oranges, they don't combine, okay? So this is the power rule for exponents. When a base is raised to 2 exponents, those exponents are multiplied. So we have x raised to the mn, we multiply the m and n, okay? This property suggests the following property of logs called the power rule. So the power rule for logarithms is pretty cool. Again, we have to have the same rules. B, m, and n have to be positive, and b can't be 1, okay? This is the same set of rules we play by for all of these. Okay, so if we have log b, base b, m raised to the p power, what we do here is we can, I always think of like cowboys and stuff, but anyway, we lasso this p and we bring it to the front, and that's how we get p log bm, okay? So the log of a number with an exponent is the product of the exponent and the log of that number. So you just always take that power and bring it to the front. Like, just lasso it and bring it to the front. Okay? Alright, let's do one. Purple. Good. Alright. Well, I kind of did this first one for you, but we have ln x squared. So we would lasso the 2 and bring it to the front, and that's how we get 2 ln x. Okay? Now this one, instead of taking a short one and breaking it apart, we're going to take a longer one and put it back together, and this is called condensing. So first we're going to do some work. So let's just copy this first one down. Let's go this way. So we're going to have 2/3 ln 8. We could do some work here, right? This is going to be ln, well, 5 squared is going to be 25 minus 1 Let's just go ahead and do that math. We can do that in our head. Yeah, that's super simple. It's going to be 24. Okay. Alright, so now what we need to do, we can also work in the reverse of this, right? So we could take the power and take it to the back. So that's what we want to do on this one. Let's do that real quick. And this is called condensing. So we're going to take this power and we're going to bring it back here. So now we can write him like ln of 8 to the 2/3 minus ln of 24. Okay, sorry, let me hit my microphone. Sorry for that. Okay. So now we see that this is a subtraction, and we know that subtraction, right? Subtraction goes to division. So let's do that. When we do that step, though, we have to make one big division bar. So let's just ln, and then one division bar. So now we're going to have, let's step over here and do this too, 8 to the 2/3. That's the same thing as saying the cubed root of 8 squared. Well, we know the cubed root of 8 is what? That's going to be 2. And if we square 2, that's going to be 4. So the answer for this guy is just going to be 4. ln of 4 over 24. Well, we could simplify that a little bit more, right? That's going to be the ln of 1 over 6. Now let's break him back apart again. So we have the ln of 1 minus the ln of 6. ln of 1 is always 0, and if we subtract the ln of 6, and that's going to give us the negative ln of 6. Okay. Now we're going to use the power rule to expand all of these. So we just want to take the power and bring it to the front. So we're going to take this power to the front. That's going to equal 4 log 5/7. This is going to be, first, before we can do anything, we have to rewrite this, just like I showed you earlier, as this with the power. So this is going to be ln x to the 1/2. Now, we can lasso this and bring it to the front. So it's going to be 1/2 ln x. And then just lasso this and bring it to the front, and that's going to be 5 log 4x. And I don't care about you breaking that one out, I just want you to bring the power to the front. That's all I really wanted you to do on those. Okay. And I put all your properties in one little place so you can find them when you're doing your homework. I thought that might make it do that easier for you. Alright, so when you're asked to expand an expression, apply the properties of logarithms in this order. The first thing that you should do is your quotients and products, and then do your powers, okay? So take care of your quotient and products, then do your powers. Here are some common mistakes. I just put them in here so that you can see, like, these are things that in semesters past that students have done. Please don't look at them and then do them. Look at them and then avoid them. Okay, so now let's talk about the condensing, which is what we just did here, like we did condensing. I don't know why it keeps doing that. That's so silly. Okay. Alright, so when you condense logs, you write the sum and difference of 2 or more logs in a single expression, okay? So when you expand, you take one log and you make it into more than one. And when you condense, you take more than one and you make it into one, okay? We use the exact same properties, nothing changes. The only thing that changes is the order that you approach it in. So when you're asked to condense an expression, apply the properties in this order. You do powers first, then products, then quotients. So it's kind of a backward process, okay? So remember that the bases, this is very important, must be the same in order to be able to combine sums and differences of logarithms. But I will never give you one that the bases aren't the same. I mean, that would just be like really dirty pool. And yeah, I won't do that. Alright, so let's condense some. So we have 2 now. Bases are the same. So we want to take them and put them together. Now we see that this is addition, and addition goes to multiplication, right? We have 2 logs. We want to just write it with one big log. Base 4, and now we're going to make a parenthesis because we're going to multiply our 2 arguments together. So we're going to have 2 times 32. Well, that's just going to give us log 4 of 64. Right? Are we done there, though? Can 4 be raised to a power that would give us 64? Yeah, I'm so far behind the mouse. Okay, so since there's no variable, we know that we could simplify, right? So this would give us 3. Same thing. Both of them are log. Neither one have an implied base, so we know that that's going to be 10. So we're going to write one big log. This time, though, this is subtraction, so we know that it's going to go to division. So we're going to make big parentheses with the small bar goes to the big bar. So we're going to have 4x minus 3, because what we come to first goes on top, what we come to second goes on bottom. Okay? Right on. Now let's do the last one. This is addition, so addition goes to multiplication. So we'll write our big log. Okay, now this one. The first thing that we want to look at is our powers. We're going to bring them to the back and rewrite it. So we're going to have log x to the 1/2 plus log x minus 1 to the 4th power. Okay. Now let's look at this. This is addition, so it's going to go to multiplication. So we're going to make our 1 log. And we know that x to the 1/2 is going to be multiplied by x minus 1 to the 4th. And these should probably, let me just fix that real quick, be brackets. Okay, and that would be that one. I'm not going to ask you to FOIL all that out. That would be just ridiculous. Okay, let's go to the next. What would our first step be here? If you said, make my thing out right, you'd be right. Move our power back, that would be correct. So we'd have ln x plus 7 cubed minus ln x. Now, we know that there's subtraction, so that's going to go to division, right? So we're going to make 1 ln, big parentheses with the division, x plus 7 cubed over x. And you can make these brackets if you wanted to, if you don't want to be like super. That's what I should have done. I just didn't look ahead and see that there was that parenthesis. And last. Okay. So, like you already know now, the first thing that we move is our powers. So that is going to give us log bx minus log b6 minus log b y squared. Ooh, there's a squared here and a 4 here. Sorry, I just completely forgot mine. My goodness, my powers. Okay, log b4 raised to, that's not even right either. Log bx raised to the 4th minus log b6 squared minus log by to the 1/2 power. Okay, now this one, since our first sign is subtraction, right? So this is going to go to division. But then we're going to put a parenthesis here, and that negative is going to be distributed. So this becomes a plus. So this is going to be multiplication. Okay. So we're going to have one big log. Base b. So we have division because of this guy. And x to the 4th is first, so he goes on top. Now we're going to have 6 squared and y to the 1/2. Okay, but we're not done. Six squared is 36. Now you could write y to the 1/2 power, either y to the 1/2, or you could have log b x to the 4th 36 square root of y. Either one of those will be fine, okay? Alright. Let's talk about change of base. It'll change your math life, probably. Your log math life, anyways. So, change of base is all calculator work. Yeah. Nothing really you could do. What I do want you to do, this is what I ask that you do. You write down what it is that you're going to put in the calculator for me. Okay, that's all I need you to do. The rest of it is just bada bing, bada boom in the calculator. Okay, so for any logarithmic base a and b and any positive number m, log base b of m is always log m over log b. Okay, so that's how you can find out what your logarithmic solution is. So the logarithm of m with base b is equal to the logarithm of m of any new base divided by the logarithm of b of that new base. So here we go. It works for ln's or log. So if you have log b of m, you always take log of the argument over log of the base. Same thing with natural logs. You just take ln of the argument over ln of the base. So how I remembered it in school was I took the bigger number on top and the smaller number on bottom. You know, I just always thought, like, in the real world, like, two people are going to fight, the bigger one usually going to win, right? Not always. I'm pretty scrappy and I'm small. But, so this is going to be log 49 over log of 7. Right? The bigger one, like the argument is the bigger number. Like, not bigger in numerical, but bigger in text. Like, font size, you know what I'm saying? So then this, you have to square 7 to get 49, so that's 2. But that's all you do. That is really all you do for change of base. This one is going to be log of 1/5 over log of 5. Okay, not too bad, right? That's all you do. That is change of base, and you're like, man, if I'd have known that from the beginning, this would have been so much easier of a lesson, right? So log of 1/5 over log of 5 equals -1. Just take 1 to the bottom. Log of the square root of 7 over log of 7. That equals 1/2 or 0.5, however you want to write it. So log of 9 over log of 81. Well, what do you have to do to 81 to get 9? Well, it's 1/2, right? Log of 1 over log of 6. That's 0. I think that is our last page, I do believe. So that is change of base. That helps immensely when you deal with logs. If you have any questions, please feel free to message me, and if not, then have a great day. And that's going to give us the negative ln of 6. Okay.